Just imagine, managing a list of thousands of students' names and removing all the duplicates instantly. That's why the Python sets concept comes in. So let's have a look to all the features of Python set one by one. So first one we have is unordered. Items in a set don't have a specific order. They appear in a different sequence each time you see them. So let's understand this with an example. Let me write a set first. Let's say s equal to 1 2 3 4, and here I'm just adding one element, let's say 100, and just trying to print s. So here actually, as per if we just go by the order, so ideally the element should be added in the end, right? That is 1 2 3 4 comma 100. But as I said, set is unordered, so we don't know in which position 100 will be appended. Let's see, once I run this, you can see the 100 is added here. So that is the features of set. We do not know the order, is completely unordered. Now we'll move to the second one, that is unique. Sets only store unique items. If you try to add duplicate, it will only keep one instance. So what does that mean? Let's understand with the example. Now in the same list, what we can do, as set does not allow duplicates, so and we'll print this, print s. So as you can see, 2 we have added 2 times. However, if we run this, we'll be able to see that 2 is removed. That means set does not allow duplicates. Okay. So third one is mutable. You can add or remove items from a set after it's created. As I showed you the example, added one, we can add. That means we can change the elements. I'll show it once again. Add 100 and we'll just try to print s, and we'll be able to see the result. And as you can see, we can add element. That means we can change the elements inside the set. That is why it is mutable. So next one is heterogeneous. Sets can contain items of different type. That means in set there is nothing like that, that we only have to add integer, float, like that. We can add any sort of elements. That is it could be string. Let's try adding some strings, random strings. We can add float. Okay, even we can add a tuple, and we just simply try to print. It will give you the output. See, we can add different sort of data types, that is integer, float, various data types. So that's why it is heterogeneous. What is the last one? That is set elements cannot be accessed using index. So in at least we have index. We in set in string we have index concept. We can access a particular element by using some index, right? So in set there is nothing, no concept like index. Let's see the proof here. So if I just simply try to access, let's say 3 to 4, it will give you simply error message. See, set object is not subscriptable. That's why set we cannot add all these elements. That is why it is unindexed. So the next concept in set we'll see a very beautiful concept, that is aliasing. Okay, so how does it work? Let's understand with some beautiful example. It will be more clear to all of you to understand this. So let's say there is one set I have. Here I'll just add the name, that is set. We'll just put set 1, and again I'll add set 2. So what is happening here? We are just, so let's say s1 is pointing to this particular object, and aliasing means what? In general, what do you understand by aliasing? We are just giving another name, right? So in aliasing, what happens? The object remains same, but you just change the name. So let's add some element here. Let's add some element here in the list. Okay, so here this is a set, and in this set we have added some element, that is 1 2 3 4, and initially it was s1. So now what we are doing, we are just doing a aliasing of s2, so that it is pointing to the same object. In aliasing, so there is no duplicate object, so no particular object will be created. It is the same object, we are pointing to different variables. So what does that mean? If we perform any changes to set 1, of course it will reflect to set 2, because both are same. I mean, it is pointing to the same object. Now let's understand this with some example. So here I'll just create s1 equal to set 1 2 3 4, and if I just simply put s2 is equal to s1, so this line, this particular line, is this is what I have done here. S1 it was initially there, and by putting just pointing to s2, we are just putting the aliasing. Now since both are pointing to the same object, if we perform any changes to any particular let's say either s1 or s2, it will reflect in the both. So let's see the example now. So now let's say we are adding s1 dot add 100. So if I just print s1 and again we just print s2, so now see the magic. I have added 100 to set 1, right? So since it is aliasing, this 100 will be added to set 2 also. Let's run this code. See, it is both is S1 and S2 I have just printed. In S1 also 100 is added, in S2 also 100 is added. Why? Because it is pointing to the same object. It's just the aliasing. There is no duplicate object. So whatever you perform in S1, it will reflect in the S2, and it is vice versa. So let's do some other examples. Let's we are adding in S2 s2 dot add, let's say 300 I'm adding and just trying to print s1 and print s2. So if I just simply run this code, both changes will reflect in the both s1 and s2. See, 300 and 300. So that is all about the aliasing concept. So the next concept we'll move is that cloning. Now coming to the cloning concept, let's just remove this. So now we'll understand the cloning. In cloning, what do you understand by cloning? It will definitely create a, what do I say, let's say duplicate object, another copy. Instead of that, we can say another copy. Let's say this is s1. So let's say this is s1 object, and let me just put this name here, that is s1, and again I'll just do s2 here. This is the s2 object. Now it will simply point, s1 will point to here and s2 will point here. So here, so let's see the code and then I'll example here. So here s1 and s2 is there. So s2 is equal to, how do we do the cloning? S2 is equal to s1 dot copy of s1. Now if I just print s2 and if I just print s1, we'll be able to see two different copies created. uh Text no argument one given. Okay, we just have to write s1 dot copy, little mistake, yeah. So here we have created two different set. Now actual cloning concept will understand what is the difference. There is a difference with aliasing concept. In cloning, what happens, you are creating a duplicate object. That means let's add some element here. Let's say 1 2 3, and similarly let's again add some element here, 1 2 3. Now in cloning, what happens, s1 is pointing to this particular object and s2 is reference variable to this particular object. So we have created a separate copy from this line. Here we have created separate duplicate object copy. So that means, from this particular picture you can see two different objects. So of course, if I perform any changes to s1, there won't be any what do I say, there won't be any effect to s2, because completely two different object, right? We'll see the code, but let's understand in conceptually. S1 and s2, we have created two separate objects, and if we perform any changes either s1 or s2, it will not affect, it is independent. So that is why it is the concept of cloning. We're creating a duplicate copy. Now let's see the code now. So how cloning is working. So after cloning, what we are doing, we are adding some element in, let's say add 100. We have added, again we'll add, let's say 200. Now s1 and s2. Now can you predict what is the output based on the explanation that I have did? Can you just do a predict? So what will happen, as I said, it will not perform s1 or s2 in, I mean, if we do some changes on s1, of course it will not affect the s2. So in this case, can you just, if you really understand this concept, can you just give a try to just guess the output of the this particular code? So what will be the output? So here what I have done, in S1 I have added two elements, that is 100 and 200. So in S1, along with 1 2 3 4, 100 and 200 will be added. However, in S2 there won't be any changes, it will be only 1 2 3 4. See, in S1 1 2 3, 100 and 200 is added, but in S2 there is no changes. Why? Because two complete different object. If you just do any changes to S1, there won't be any effect to S2. So this is the concept of cloning. I hope it's clear to all of you. So the next concept we'll move is the mathematical operation. So we will see that how a mathematical operation is being performed in set. So let me just take two set first. I've just taken some random element. So in set, basically in set it does not support mathematical operation. We'll see the proof here. What I have done here, I just taken one set 1 here, and I've just taken set 2 here, and I'm just trying to print it. S1 and S2, I'm just trying to add it. Let's say what happens, it will give you simply error message. See, unsupported operand. So we said we cannot perform any operations. Let's try to do multiplication here. Here also we are getting some exception, I mean the error message. If I just try to do division, it will give you error message. So instead, what you have learned, mathematical operation is not possible. Now next we'll see the equality operator. In equality operator, what happens, what is the condition, s equal to s2. So for an equality operator, just let me do the commenting. Equality. So in equality operator, what happens, if I mean s1 equal to s2, it will return true if and only if all the elements are same, and an order is not important. Why order is not important, we have learned. In set it is unordered, right? So the condition is the element has to be equal, and it is of course case sensitive because Python is case sensitive, right? So here the condition is to return it true is that the element has to be equal and the order is not important, but it is case sensitive. So in this case, based on the explanation, can you guess what will be the output? It will return false. Why? Because you can clearly see s1 and s2, the elements are not same. Here it is 1 2 3 4, here some extra elements are there, right? It will return false. So what, so now if I just do some little modification, let's say I'll just keep it 4 and I'll just add 1 here. Yeah, so now it will return true because all the elements are same. Now what I said, the order is not important, we can change some order. 4 comma 3, I'll take it here. So as you can see, 1 2 3 4, 1 2 4 3, order is not important, but all the elements are same, so it will return true. Yeah, so this is how it is works. So this is all about the Python equality. We'll see the relational operation in Python. In in set, relation operator is applicable, but in what basis we don't know, basically. So I'll show you. It will not give you any error message. It will not give you any error message. However, in what basis, there is no logic. I mean, we don't understand in what basis it will perform. So what you should know from the relationship operator, let me just change relational operator. In relational operator, we don't know in what basis it will change. It is simply I mean, there is no logic. It will just simply give you output instead of exception. So this is all about relational operator. Now we'll see membership operator. So membership operator, what we have one is in, another is not in. One is in, another is not in. So we'll see how it's work. It's very simple actually. So if I just simply try to see one in s1, so it will just if we understand from this particular diagram, it will be very easy for us to understand. So let's just consider this is, let's say, s1. So see, it will just say, if I just see we can see in set, let me just put it a reference. Yeah, so this set s1 is the reference variable, and what are the elements available here? That is 1 2 and 3. So what membership operator do is that it just simply checks whether the particular element is present in this particular list. So if I just say 1 in set 1, it is available, right? So it will return true. If I just see 2 in set 1, it will simply return 2. Why? Because the element is present here. Now if I say 100 in s1, 100, right? I'm just saying 100 in S1. 100 is not in the S1, right? Say it is only 1 to 3. So of course it will return false because this element is not there, right? So let's see from the code. So here, if I just simply run it, it will return true. Why? Because 1 is present in set 1. Yeah, it is true. Just simply, if I type 199, 199 is, from the set 1, you can clearly see 199 is not present here. So of course it will return you false. See, so it is returning false. So this is how membership operator works in set. So the last concept for today we'll learn is the set comprehension concept. So how does it work? So let's say there is some elements in the set and you want to find the some square elements for a particular range. Let's say you want to find the square of from 1 to 10. So how do you do that? By using set comprehension you can achieve the same. So in set comprehension, what we are doing here, how do you are achieving this is one of the example here. What we are trying to achieve, we are trying to find the square elements from 1 to 11. I mean, that is range function. We know that works for 1, I mean, begin to n minus 1. So it will give you the square elements for each element from 1 to 10. So if I simply run this, so it will give you the square of each element 1 to 10. Why it is not in order? Set, because set is unordered. So this is the set comprehension concept. So by applying this, you can achieve this square of each elements. So this is how set comprehension works. So so what we have discussed today, so you can just we can just revise from the beginnings that we have discussed the Python set, that is unordered, unique, mutable, heterogeneous, and unindexed. We have checked some mathematical operator, equality operator. We have checked mathematical operator. But this is how set comprehension works. So that's all for today. Thanks everyone for watching this video.